Last time we discussed the regulation of body functions. And we know body functions are maintained by neural regulation, hormonal regulation, and autoregulation. These regulatory systems constitute the control systems of the body. And these control systems enable various activities to be more coordinated, so that the body can adaptively react to the constantly changing environment. So this time, I'll introduce the control systems of the body. After we complete this session, students should be able to explain how a negative feedback mechanism and a positive feedback mechanism work. Compare the effects of these two feedback systems on the body and predict the consequences of a failed negative feedback. There are thousands of control systems in our body. The fact that we remain alive is the result of these complex control systems. They are powerful in coordinating the functions of organ systems to maintain homeostasis. The control systems of the body involve a cycle of 4 components: variable, receptor, center or integrator, and effector. Variable is the factor or event being regulated. Sensor or receptor monitors the environment and responds to changes. In physiology, changes in the environment are called stimuli. The receptor sends information to control center. The control center or the integrator determines the set point. Set point or set limit is the level or range at which a variable is to be maintained. The control center also analyzes the information it receives and determines the appropriate response or action. Then, the information is transmitted from the control center to the effector. The effector is the structure where the activities occur in response to stimulus. The results of the response are then fed back to influence the effect of the stimulus, either reducing it or enhancing it. This is called feedback regulation. There are 2 types of feedback: negative feedback and positive feedback. Negative feedback reduces the original effects of the stimulus, while positive feedback produces enhanced effects. Most homeostatic control mechanisms work where negative feedback. The resulting effect shuts off the original effect of the stimulus or reduces its intensity. In negative feedback, the variable reacts in a direction opposite to that of the initial change, returning to its ideal value. Thus, it is named as negative feedback. For example, the ideal body temperature is 37 degrees centigrade. It's about 98.6 Fahrenheit degree. The temperature control system functions like an air conditioner. It operates at a set point of 37 degrees centigrade. If the body temperature is 37 degrees, nothing needs to be done. And if the body temperature is higher or lower than 37, the internal receptor senses the signal and reports it to the control center. The control system then starts to run to bring the body temperature back to 37 degrees centigrade. Another example of a negative feedback mechanism is the control of blood sugar by insulin. As blood sugar rises, the pancreas starts to secrete insulin into the blood. Insulin in turn promotes body cells to absorb more glucose. And so glucose is removed from the bloodstream. And as blood sugar falls, the stimulus for insulin release is shut off. So every day our blood glucose fluctuates as we eat or drink. It is through negative feedback mechanism that our blood glucose level remains within a normal range. Negative feedback control plays a critically important role in the regulation of body functions. Most body functions are controlled through negative feedback mechanisms. In addition to body temperature and blood glucose, other examples such as the heart rate, blood pressure, blood volume, breathing rate, blood pH, water and sodium balance, etc., are all maintained at physiological ranges by means of negative feedback. And all these negative feedback mechanisms have the same goal: preventing sudden big fluctuation within the body. Then, how about positive feedback? In positive feedback, the result or response enhances the original stimulus so that the response is escalated. This feedback mechanism is positive because the change that results proceeds in the same direction as the initial change, causing the variable to deviate further and further from its original value or range. For example, when you cut your finger, blood starts to come out, and bleeding stops within a few minutes because of the formation of a blood clot. This blood clotting is a normal response to a break in the wall of a blood vessel and is an excellent example of positive feedback. Basically, once a vessel has been injured, platelets immediately begin to stick to the injured site. Platelets then release chemicals to attract more platelets. And so, very rapidly, the pile-up of platelets temporarily plugs the tear and initiates the sequence of events. And finally, a clot is formed and bleeding stops. Another example of the positive feedback mechanism occurs during the birth of a baby. Oxytocin is a hormone from the pituitary gland. During labor, it causes uterine contractions to become both more frequent and more powerful. The increased contractions cause more oxytocin to be released, causing even more and stronger contractions, and so on, until the baby is finally born. The birth of the baby terminates the stimulus for oxytocin release and closes off the positive feedback mechanism. So positive feedback mechanisms usually control infrequent events that do not require continuous adjustments. And typically, positive feedback mechanism triggers a series of events. And these events, once initiated, produce an amplifying or waterfall effect. So, positive feedback mechanisms are often referred to as cascades. And the cascade reaction is likely to get out of control, causing the vicious cycle and even deaths. So this is because the positive feedback does not lead to stability. Rather, it causes instability and homeostatic disturbance. Again, let's go back to the case of Lily. Overexposure to a hot and humid environment makes normal heat loss processes ineffective. This results in elevated body temperature and inhibition of hypothalamic functions. At a core temperature of around 41 degrees centigrade, it's about 105 Fahrenheit degree. Heat control mechanisms are interrupted, creating a vicious positive feedback cycle. Rising temperatures elevate the metabolic rate, and which increases the heat production. The skin becomes hot and dry, and as the temperature continues to go upward, multiple organs are damaged, including brain damage, if no intervention is initiated immediately. Our well-being depends on thousands of powerful control systems in the body. As we age, our body's control systems become less efficient, and the internal environment becomes more and more unstable. So this is why the risk for disorders increases as we age, and why many pathological changes are associated with senility. In summary, control systems of the body work through feedback mechanisms. Feedback can be negative or positive. Negative feedback is the most important and common mechanism for regulating body functions. In general, if a substance becomes excessive or deficient, the control system initiates negative feedback. Negative feedback restores homeostasis. On the other hand, positive feedback returns the substance towards a certain mean level, thus maintains homeostasis. So that's all for today, and this is the end of Chapter 1. Next time, we'll learn physiology of the cell. Thank you, and see you next time.